circular motion, and we're using the concept of the different when there is a wheel. Okay, uh, in this circular motion we'll be using so you can see the question which I have written over here also. So a cord is wound around a wheel. Okay, a wheel is given to you and a cord is wound around a wheel. That means it is the cord is wound around a wheel. So if this is the wheel, let's say if this is the wheel, okay, and the axis is here, it's also given that the diameter of the wheel is 0.3 meter. So this is given as 0.3 meter. So the radius will be 0.3 divided by 2 meter, right? Because radius is the half of diameter, right? Now it's also given that the axis of wheel is horizontal. That means the axis is passing through it, right? It's not vertical, it's horizontal. That means wheel is looking flattish from front, right? Now the mass of 0.5 kg attached at the end of the cord, right? First of all, we need to understand the cord is wound around the wheel. That is, it's rotated around the wheel, right? So we can say the cord is just rotated like this. Okay, it can be of multiple rounds, but it's not mentioned here. So you can just see that's across the wheel. That means the cord is wound around the circumference of the wheel, right? And through the a mass of 0.5 kg attached at end of the cord. Suppose this is the end of the cord which is hanging like this, right? Then at this end a mass is attached, okay, and that mass is of 0.5 kg, right? This is given to you. Now this part is covered, that is diameter is 0.3 meter, which we have taken. 0.3 by 2 is the radius. The mass we have considered attached at end of the cord, allowed to fall from rest. That means when the mass is initially, the initial velocity u is given to you as 0 because it's allowed to fall from rest. Mind the word rest, right? So that means the initial velocity is 0, right? If weight falls 1.5 meter in 4 seconds, so the another data given into the question is 1.5 meter is the fall and in time of 4 seconds, right? So S is given to you as 1.5 meter and in the time of 4 seconds. Hi train edits, good morning. And we need to find the linear acceleration and angular acceleration, right? So we need to find this linear and this angular acceleration, right? Students, we know the formula S equal to ut plus half at a square. So in this, the A is the linear acceleration. This A is the linear acceleration whose value we are going to, which value we are going to calculate, right? This is asked to us. Now here S is given as 1.5 meter. Just use this value. So in place of S, just write 1.5 meter. Since the value of u is 0, this term will be coming as 0, right? Now half at a square, half will be half 1 by 2 into a into t square. What is the value of t? It's 4 seconds here. So it will be 4 square. So this will give you the value of a, that is the linear acceleration. Just solve it. 1.5 into 2 is 3. So 3 by 4 square, that is 16. So 3 by 16 meter per second square is the value of a, which is linear acceleration. So this value is calculated 3 by 16, right? Now we are going to find the angular acceleration, right? I hope you remember the formula of angular acceleration. That is, if the body is suspended from here and this is the radius, okay, and this is the radius, right? Then angular acceleration generally denoted by alpha, is denoted by alpha, right? It's related as, it's related with linear acceleration a, as a equal to r alpha, right? Where a is the linear acceleration. So just put up the value of this 3 by 16 over here, 3 by 16, right? Put up this value of 3 by 16 over here, equal to r. R, what is the value of r? Since 0.3 meter is the diameter, right? So r will be equal to 0.3 by 2, right? This is meter and this is meter per second square, right, into alpha, right? So this will give you the value of alpha, which is our linear acceleration. This value we need to calculate alpha, okay? Alpha is the angular acceleration and a is the linear acceleration, whose value we have already calculated, 3 by 16 from here, right? So this will give you, 1 minute, yeah, this will give you the value of alpha. Just leave alpha into one side of the equation, and here you can see 3 and 0.3 will be cancelled with leaving 10 in the denominator of the RHS. So we are with 10 into 2, 20, 20 by 16, 20 by 16 is this value, that is 20 by 16. That means this is coming as, this will be in radian per second square. So this will be coming as 16 1 16 4 16 2 32 8 16 5. So the angular acceleration is calculated as 1.25 radian per second square. This is the unit of angular acceleration, right? So in this way we have calculated the second part of the question, that is the angular acceleration, and the linear acceleration we have already calculated. So in this way we have solved this question, right? If you find it useful, you can like it, okay? I hope definitely you will find it useful, yeah. So the value of angular acceleration is calculated and linear acceleration is also calculated. Thank you so much for watching, yeah. Any doubt you can put up into the comment box, right? What we did, based upon the given data, we applied the formula S equal to ut plus half a t square. Since the body is falling from rest, so we have taken u equal to 0. So the data which is not used into this question is the mass of this 0.5 kg. This is not used anywhere, you can see, right? And also the second part, that is for calculating the linear acceleration, okay, we did use the formula a equal to r alpha, and which is simply putting the value of acceleration, linear acceleration, which you have already calculated, we derived on the value of angular acceleration, right? So I hope you find it useful. Just like if you find it useful. Thank you so much for watching, students. Take care. Bye bye. Bye bye.